Alright, so I'm going to record the answer to the test. Um, yeah, so a few people told me that they did not quite understand the question. So let's see if I can help explain that. I cannot make any decision based on not knowing, how the class in general did in the class. So I'm going to have to wait until I take a quick scan at the answers, and then I'll decide what to do. All right, so this is question number one, and so I was just looking at the text channel. So anyway, so right here we have the first question, and your questions are not going to be ordered the same way, in terms of the characteristics. So the first thing I want to explain is what f is. So f is two things. F is both a set of two tuples, and it is also a function. It can do both at the same time. So the first thing here is we are creating a set such that. So you hear that phrase a lot in this particular exam, is such that, which is basically adding some constraints as to what can be elements to a particular set. So in this case, the membership in X is specified by this particular statement here. There exists xy in f if and only if x is in x. So lowercase x is referring to the first item of a two tuple that belongs to f, and then uppercase X is the set that we are actually constructing. And that's why I send a little announcement ahead of time to remind people that variable names are case sensitive so that we don't confuse which X is which X. So what this statement is really saying is to say, if there's at least one, of whatever two tuple is in F here, with X as the first member of the two tuple, then X is going to be lowercase x is going to be in uppercase X. In other words, I'm using this to collect all the first item of every two tuple of F, lowercase f, into uppercase X. So uppercase X is naturally the domain of the function. So in this case, you look at every single two tuple, and I'm going to highlight a two tuple here. So this is a two tuple, and whoops, I highlighted too much. Let's see. There we go. So this is one two tuple, and of this particular two tuple, the set of three is the first item. So that's why we have three over here, and then we have 3 4, and I got one too many braces here. There we go. And then we have 6 1 2, and then we have 2, and then we have 5 3. And these are, so each element of X by itself is also a set, because whatever is the first item in a two tuple of F becomes a member of uppercase X. So Y is kind of the same thing, except it's referring to the second item. So this time, we have the value 3 without the set notation around it, the value of 7, the value of 9, the value of 2, the value of 8. So these are elements of Y. So given that we have X defined this way and Y defined this way, P1 is actually going to be true. So there's really not much to explain here, because P1 is always going to be true. Alright, so if f is not a function, explain why it is not a function. It is a function, okay? Because every element of the domain is mapped to one and only one thing in the codomain. The very way we define x ensures that P1 is going to return true. Alright, so there's not much to explain over there, and the confusion is mostly revolving around this part of the question, the second part. This part should be answered only if f is a function, and we confirm it's a function because p of 1, the predicate, is returning true. So I think the most confusing part has to do with this sentence here. So I actually thought about this quite a bit before I put it in. So let me see if I can explain that a little bit better. All right, so the first part here, in parentheses AFA, that's referring to a two tuple that is an element of F. In other words, we are looking at, F here, and we're looking at its elements. Okay, so we're looking at this element, we're looking at this element here, and so on and so forth, and we're asking which element can be FA, because the first item in the two tuple is uppercase A, and the second item is f of A. It's after we apply function f to A, then we have f of A, and this is basically self-explanatory in a certain way, because f is already known as a function because it passed p1. So that means when we look at each tuple in f, it has to be the first item is the argument, and then the second item is the result of applying f to that argument. So now we have three basically placeholders. We have a, b, and c as placeholders. Now the key here, the most important part here, is the phrase such that. So we need to make sure that a does not equal to b, A is not a subset of B, B is not a subset of A, and C on top, is the intersection between the sets A and B. So, so now we have a lot of constraints, right? Because we know A has to be the first item of A2 tuple in F. Same with B and same with C. But on top of that, we also know that we want C to be the intersection of A and B. And we also want A not to be a subset of B and B not to be a subset of A. So without these extra constraints here, let me highlight which ones I'm talking about. So without these extra constraints, then A, B, and C can be the same thing, because then it would be very easy to meet all of these constraints. But having these extra requirements means A, B, and C cannot be the same, and as a result, now we actually have to hunt for these A, B, and C. So in this specific case, okay, just looking at X really helps, because X is telling you all the potential candidates for A, B, and C. So now you just have to find basically C is going to be the one with the least number of elements. A and B potentially is going to have a more elements. So now we just take a look at this case. So I think I have just found it, because 5, 3, and 3, 4, they have an intersection of 3. They do not equal to each other. C is a subset of A, and C is also a subset of B. That's just coming from C being the intersection of A and B. But A and B, on the other hand, are not intersections of each. They're not subsets of each other. Sorry, I misspoke. So A can be the 3, 4, and then B can be the other one, which is 5, 3. And then C is going to be the intersection of those two, which means C is going to be just having the element of 3. But they're all sets. Okay, A, B, and C are all sets in this case. So now we want to define D as A minus B, which means it has all the elements of A that is not found in B. And you can see that A has 3 and 4, B has 5 and 3. So if you want to only include things that are in A but not in B, we only got one thing left, which is 4. And now we define H as F union with this thing here. So for the most part, okay, this is why I mentioned earlier, I think in the announcement, that copying and pasting is going to save you a lot of time, because look at this. I just copy and paste, and then we can just add the one that we need to add here. Okay, so we just add one more element, and the one element that we are adding is this element here. This is the element that we are adding. Yeah, I can hear Discord here just going like crazy, because you guys are all kind of talking in the text channel. So I'll get to that in just a little bit. Alright, so we want D to be the first item in the two tuple, so that's going to be just 4. And then the second item in the two tuple is going to be f of A minus f of C. So in order to find out what is f of A and f of C, we kind of need to go back to the definition of f, and we know what is A already. Let's see. We need to go back just a little bit more. All right, there we go. So A is 3, 4. So f of A is a 7. C, on the other hand, is just 3. And f of the set of 3 is 3 itself. So we have 7 minus 3, which is also 4. But that's the numerical value of 4. It is not the set of a value of 4. So this is what we are adding. Okay, just to emphasize what I have added here. This is what I have just added. All right, so now that we know what h is, we're going to look at v. V is kind of doing the same thing as x. So for the most part, you can just copy and paste x into the content of v, and just add that one extra thing that we have just added, right? So we have just added d to the whole thing. So d is the set of just 4 in it. There we go. And then w is basically just y with one more element in it. So we look at what y is. There you go. All right, so here's y, and we paste it, and we just have to add that one extra value in the codomain, which is the value of 4. So based on how we define v and w, given that we have h as a set to consider, this is how we can make sure that p of 1 is going to return true, because by the way we construct v and w, we are giving it a domain and a codomain. So this is true. Is h a function? And if so, is it injective? The answer is yes or true. It is injective. It is injective because it was injective to. Okay, let me double check, because it's possible it's not. Let's see, 379,284. So I don't see any value as a second item in the tuple repeating, and as a result, it is injective. And since it's injective, we don't have to answer this part, which is saying if h is not injective, then explain why it is not injective. So we don't have to answer that part. Alright, so I'm just gonna stop the recording for this part and upload it, so this way you guys can watch it right away. I know some people are anxious to watch